Melbourne, Melbourne team, so he'll start and I'll wrap it up. Presentation.
I've only got one slide to present, so I don't want to take Michael's thunder. By a show of hands, how many of you have heard of Elastic or ELK? Well, I can just go then. How many of you are using Elastic Stack or ELK Stack for powering the search for your websites or applications, or powering enterprise search as well? Okay, a few. How many of you are using the Elastic Stack for log management? Anyone using it for security analytics or building their own scene, if they are? No? That's what I figured. So for those of you who are familiar with the stack, I think it's almost everyone here. I just wanted to go through really quickly, give you an overview of the Elastic Stack. We still call it the ELK Stack. It's just tough to find a suitable name that includes beats as well, so maybe belt or LB. But you'll know that it's based on, or it's formed by three different layers. Beats and Logstash form the ingest layer. Elasticsearch is our storage layer. It's our search engine and the analytics engine as well. It's the heart of the stack and the company as well. Some would argue that the people are the heart of the company, but anyway. And then Kibana is our product, which is the management and visualization product. So those are the three stacks. That's the three layers that form the stack. What you see right now is open source, and on top of that we have additional features, and we have support as well as consulting and training, which we provide as part of a commercial offering or commercial relationship. But on top of this, with the stack, we've created many different solutions or products that power website search, that power application search and enterprise search. That falls within the search category of solution. And then we've also got the analytics side as well, which most of you already know. It's starting to become more common that the Elastic Stack is being deployed for logging or acting as a centralized log management solution, as well as security analytics, whether it's that could mean many things for our users and customers, but predominantly we're seeing it being used as more of a SIEM solution or an augmenting current SIEM solutions. The one that I didn't touch on, which is application performance monitoring, I didn't want to talk about that, so I'll hand it over to Michael, and thank you for the organisers and for you here tonight.
So hi everyone. So Elasticsearch. Elasticsearch is a search technology, right? And we're an Elasticsearch company, so many problems that we solve, they look like search problems. It was built, so Elasticsearch was built as a search engine around the patch of the scene, and very soon after it was sort of released as an open source tool, people started using it for log aggregations, because the first thing you want to do with logs is search through them. So soon after logs, it became de facto storage for logs, talking about back in 2012, 2011. People wanted to put metrics, so metric being numerical values, CPU utilization of your servers, memory utilization, number of people visiting me in a period of time. So Elasticsearch became a metric store. And then later on, Elastic as a company joined forces with another company called OPB, which was building open source APM solution. So we kind of carried it forward, and our APM solution is what we call the third pillar of observability. So you have your logs, your metrics in Elastic Stack. So now we're going to be talking about APM in Elastic Stack. And it's actually quite a big differentiator because there are open source projects that deal with application performance monitoring. You may be familiar with Zipkin or Jaeger. There are commercial APM products, you name them. They cost money. we kind of found the sweet spot that we are the first vendor supporting behind an APM product. So it's a quite unique place, and it's quite a big disruption to the APM market, and we kind of see a big wave of adoption. So what is APM? Let me just talk a little bit what problem we're solving with APM. So application landscape, when you look at it from the infrastructure perspective, it becomes quite complex. You've got multiple data stores, you've got multiple technologies that you have to use, multiple network solutions, and things just getting more and more complex because we're adding layers of abstractions, we're adding Kubernetes, we're adding virtualization, we're adding, we've been using VMware for quite some time, for example, or other visualization layers. And because of the layers of abstractions and different technologies that we may use, not just Java, sometimes, some organizations adopt microservices. So pretty much anything goes. Python, and you've got a core team of people, what we call a two-pizza team that know Python. Go and build your building a microservice with Python. And then that becomes a microservices world. So you end up with lots of different technologies, and you build your application, and then something like that happens, right, to your users. So, and that basically everyone's favorite moment of quote unquote, then where is the problem? So what is actually broken? Now, traditionally, that's where you start the day with looking at different log files and different tools, trying to understand. Every stack will come with their own monitoring tool set. You've got the good old log files, so you go and SSH into boxes and tail log files and look at timestamps. And it's quite painful looking at timestamps and trying to debug timing issues or user-facing errors from by doing that. It's just horrible, in my opinion. Some people may like it. So the industry came up with the concept of distributed tracing and application performance monitoring. And this is the way where we instrument our application components with agents, and we get a something like a view or similar to that, a view which is similar to that, where it shows us how much time a user request spends in different components. And distributed tracing has the capability of stitching together, the timestamp and understanding dependencies and passing the correlation ID, so you can actually plot the picture of where the latency is actually spent. Okay? So that's what APM does. It's actually quite a good starting point when you have to debug timing issues or latency issues or user-facing errors. So the distributed tracing started its life from a paper basically produced by Google, I think somewhere around 2009, 2010, and they introduced it in a tool called Dapper, which then evolved and became another open source project called Zipkin. By the way, Elasticsearch is also used in these products. In these projects, so Jaeger and Zipkin, they have the option of using Elasticsearch as a backend store for the spans. So even before Elastic kind of had an APM solution, Elasticsearch was already used as a backend store for some of the open source products, as well as commercial, actually. Companies like SignalFx, for example, they're big Elasticsearch customers. So microservices can be very complex. So who here is basically not doing monoliths? Who's here doing microservices? Yeah, it becomes quite popular, right? And the more you do them, the more complex they become, because then, typically you start with one monolith and you're splitting it into different parts. And then as basically logic becomes more and more complex, your microservices kind of being split into different pieces. So organizations like Netflix and Twitter, this is kind of interdependencies and a number of microservices they have to deal with and understand how they talk to each other, right? When you have a single user-facing application and your backend is looking something like that for the Netflix, it's mandatory to have a tool that actually shows you where the latency is spent and how the components interact with each other, because you can't just humanly comprehend it from the log files or just looking at your metrics where the problem is occurring. So distributed tracing is basically a way of tracking latency. So distributed tracing in APM is all about measuring how much time the end-to-end request took and then breaking it down into sort of underlying latencies, and basically breaking it down to even to the level of pieces of code that are involved in basically getting a particular request process. All right, so when our end user is experiencing an issue, our APM can actually point us that 90% of the latency for that particular user request was spent in my accounting service. By the way, if you have any questions or you want to make a comment, feel free. Yeah? I'm all in for making it more interactive. So as I mentioned, Elastic APM is the first major open source APM solution in terms of agents, servers, and dashboards. We introduced, so we'll talk about it later, but it's actually quite a powerful statement. So being able to, you don't just download the software and use it for free. That's actually quite a powerful statement in the market. So we kind of see a lot of people not just downloading and trialing it, but also contributing back. So we're seeing a lot of third-party agents, for example, for technologies that we didn't think they're that used. For example, we have people writing agents, PHP agents. Or someone went and built a Delphi agent for Elastic APM. Apparently, it hurts someone enough to make them go and write it. Okay, and it just works. So we have a sort of a really big community behind us. So if you know Elasticsearch and the community behind Elasticsearch, that's what you get with Elastic APM. So for those who are familiar with Elastic Stack and the ingest, so we've got our traditional ingest with log session beats collecting the information, pushing it into Elasticsearch and visualizing it in Kibana. So APM in Elastic Stack is built as a parallel ingest layer. The data still ends up in Elasticsearch. So it's actually quite useful. So if you're thinking, so I mentioned that Elasticsearch is being used for log aggregation, but also being used for metrics. You can also use, so the same data ends up in Elasticsearch, basically. The APM data ends up in Elasticsearch, which is quite handy, because then you can start creating, for example, dashboards that show you your request latency compared to the CPU utilization of your servers. And then you can create alerts that say, alert you on the combination of, I don't know, for example, an increased number of errors coming out from a particular component, then basically correlated with increased latency of your APM span. So it's quite a unique value proposition because it actually gives you the kind of the overall end-to-end observability package. We need to instrument your code with APM agents, and we've got agents for all the major languages that we support ourselves, and there's third-party community agents that people are building. Agents are talking to APM server, which is just a proxy translating the information that APM agents collect, and push it. Everything is pushed into Elasticsearch, and Kibana is used to visualize everything. As an indication, so it's free and open source, so UI application is basic and free, so it's free for end users. The code is available. The rest of the componentry is open source, so it costs you nothing to get started. So distributed tracing, we already mentioned, so basically it's a way of basically not just tracing latency errors, but also looking at errors when a certain component being invoked, so pinpointing errors to a particular link in the chain of your request processing. For example, a database failure, right? So it occurs in a particular leg of the request. We can actually capture the exception and show it where it occurs in the request. We call APM as a tracing, or APM as a third pillar of observability. So you're collecting your logs in one place, you're pushing a matrix into a store, and then tracing it just complements the kind of the observability as a discipline. Right? So this is what we're looking at. So Elasticsearch brings logs, matrix, and APM together. We provide you with sort of a single solution, which is open source across all the major technologies. This particular slide, it just displays the technologies we support as a company, so agents that we build as a company. So Java is right there. We support sort of Flask and Django and Python and JavaScript. Real user monitoring, so JavaScript writing in Node.js and JavaScript writing in the browser. So we can instrument the browser side as well. we've got Ruby, and we have .NET. So it's not on the slide, but we've got .NET. Actually, to illustrate how fast we're going, and again, all that is open source. So how fast we're going. So as of, I think 10 months ago, we didn't have a .NET agent, and now we have it in GA. So supporting .NET Core, ASP.NET. So we're investing quite a lot of effort in basically our APM solution. The key features, APM is all about tracing response time for requests. And it's actually a very good starting point to debug latency and issues or user-facing areas, because then you can see which leg of the journey of the request is broken. We capture all the unhandled errors and exceptions. So if you're basically not catching an exception, the agent will catch it and will log it with a stack trace, and we'll see how it's basically handled in the stack. Visualizes call hierarchy, so the waterfall chart. Now the missing piece is service maps. So I don't know if you're familiar with APM tools. You can also get a visualization how basically a particular request, which component it touches in some sort of a graph view. It's in the making. So right now we're doing a visual call hierarchy. We can identify code bottlenecks by just collecting latency for sort of the same piece of code across multiple requests. So we can say at what time of the day and when, under what conditions this particular code is behaving abnormally. We can drill down to the code level, which is quite useful because we've got stack exceptions, stack traces. We can sort of drill down to the code level. We can basically drill down to the method level. There's quite a lot of other instrumentation going on, by the way. So if your web application is implementing a servlet API or a JDBC API, the agent can just observe it and auto-instrument it. So we understand sort of key frameworks and key APIs and key interfaces used in application development. So APM UI is a Kibana plugin. It's built basically specifically for APM visualizations. It's a developer tool, so it's not just a production or operations support. It's actually quite a useful way to profile your code or just run it in your pre-production environments, run it locally, run it alongside your performance testing tool or even sort of other testing suites, and get an understanding what the bottlenecks are. So whether code is running slow, under what conditions, what are the exceptions, what are the exceptional statements. It's free, it's on the basic license, and it's integrated with the search bar because as Elastic Company, everything is a search for us. So why not give you a search bar in your APM tool to look for, I don't know, all the requests coming from a particular user because he's complaining too much. All right, so you can see what are the requests doing for that particular user or a particular user agent. A particular user agent, basically, if someone's using, I don't know, Explorer 8 still in your user base, and you probably want to flag it. So APM data, just latency data, and it becomes another index in Elasticsearch. That's why it's so kind of easy to mash it up with other data if you put it into Elasticsearch. You can customize the dashboards with whatever visualizations make sense to you, right? Which is quite useful. You're not confined to the kind of out-of-the-box kind of visualizations that tool creators thought will be useful to you. So you can build your own. You can mix it with other sort of stack features which are quite useful in the combination with this data. We have built-in integrations, but there's quite a big community building stuff around Elasticsearch and Elasticstack. So there's third-party machine learning, third-party alerting, third-party visualization tools. It's quite useful. This is just kind of what you can do with Kibana, which is quite cool. Types of graphs you can visualize and type of things you can put on the visualization method. So getting started with minutes, you can download, drop a few lines into your application, configure it to basically point it onto Elasticsearch, and then you can see it in the APM application. Now, Kibana with APM UI comes with installation instructions, so you can select the technology that you use, and it'll give you the installation instructions. For Java, it's quite simple. We're using Java agents, and we can just attach to Java applications at runtime. We can even sort of attach to a running process by process ID. So Java is actually supported. So for Java, you may not even need to add any code to your application. For other languages like Node.js and Python, you do need to kind of instantiate your agent in the code. Any questions? I'm gonna go into a demo. Any questions about APM, Elastic? Yeah?
For this kind of tool, can you run it jointly with load testing tool?
So if it's possible to run it in conjunction with a load testing tool. Actually, one of the things I'm going to be showing in the demo is the integration with another bit from the interest layer called Heartbeat, which acts as a periodic sort of ping of an endpoint. It's not necessarily a load testing tool, but it's a way of monitoring uptime. But you can substitute it with like something like JMeter and inject transactions into your application, and then monitor, do performance testing, and understand where the bottlenecks are. You can definitely do that. So, you know, anywhere you trigger the application, APM agents are going to just measure the latency and just record the data. So for the demo, and I'll actually publish it. Yes, sorry.
Your dashboard showed even the queries being logged, right? And
Sorry.
the dashboard,
Yep.
regarding the metrics, it also showed the query times. So how exactly you're sniffing it through the application?
So query times.
Yeah, query times.
Yeah, we'll have a look at it. So in the application, Java application, when we instrument the app, we basically discover all the classes implementing, say, for example, JDBC APIs. So when we discover a method that implements, we do a bytecode instrumentation, so we use bytebuddy. We find the method that runs JDBC, I can't remember the method, but we find the method that JDBC interface, for example, uses to run a SQL query. We understand the parameters. So we can wrap the agent around that method and say, this is when it starts, this is when it finishes. Parameter number one is your SQL statement, and we can capture the SQL statement, so we can see that in the demo. But that's how we do everything in APM. We basically wrap ourselves around a particular method, and then we basically measure the latency from start to finish.
So even between the methods, you have the latency being captured.
So you can capture, you can create additional spans within the method itself. You can, for example, add your own instrumentations. Or think about if you're instrumenting a component, right, that starts from a servlet API. So we capture a servlet API, so from start to finish. Within the servlet API, at some point, there's going to be a call to a database, JDBC API. So we'll wrap ourselves around JDBC API. So we'll get a nested servlet request, and then, so you'll get a servlet request, and then a nested JDBC API request within that servlet request. We'll see it in a second.
Basically, my question is that it's going to impact the performance? Because you have pinpoint today, you're going to have the pinpoint being installed. During your performance, you usually use it. Whenever the performance delays, that's when you activate pinpoint and see exactly where. So it has a performance impact for it.
So does it,
So
well, yeah, the question is what performance?
when you're going to do it, yeah, what is the performance?
Yeah, that's a very good question, right? Because we're measuring things, and by measuring things, we're affecting things. So everything in the APM agent is trying to minimize the impact, but there is you need to spend cycles to kind of, execute the code and pass it on. For example, we've got an internal queue, but all the measurements are served using a sort of asynchronous thread. So everything is reported to the server using asynchronous thread. So you kind of take the minimum possible amount of time to measure things, but you have to kind of instrument things to measure them, and then it changes slightly. In reality, there's no impact. So I'd say it is negligible, but you can check it for yourself. So I'll make the demo public so you can actually download and play with it. It's built on Docker and Docker Compose, so it's quite easy to basically clone the GitHub repo and get it up and running. The GitHub repo has the instructions. Don't worry about capturing it now. I'll post it to the meetup notes with the presentation, so you'll have it. So the setup is basically, it's a web application, it's a pet clinic application, and we have basically Elasticstack running the APM server, Elasticsearch in Kibana. We're running a pet clinic application, which is a Spring Boot with Hyatt SQLDB. We've instrumented the pet clinic application with Java agent, Java APM agent, and we've instrumented the browser side with real user monitoring agent. So these are two agents that one of them is measuring browser-based sort of performance, and the other is measuring the Java side performance. They work in conjunction, so they create traces together as a distributed trace. So it's two technologies actually creating traces simultaneously. We've got an Nginx components just to get around the cross-site scripting, so just acting as a proxy. So the browser can report to the APM server. We have a heartbeat component which injects traces. It's another aspect of Elasticstack, or another basically area of Elasticstack which we call uptime monitoring. Very simple component that basically all it does is it can either ping your servers, or it can send GET requests or POST requests to your infrastructure. So you can basically, and doing it periodically, it basically reports back to Elasticstack and then says how long did the round trip take and what was the response status. So if your server is down, it will respond basically if my server is down. So that's the demo. Let me actually show you the demo. So here we have a pet clinic application. It's just a good old pet clinic application running on Spring Boot. So the Java side is auto-detected entirely, so there's no changes to the Java code. The only thing that we changed, because it's a server-side rendered framework, I've added generation of a trace ID to their templates. There's a couple of lines, changes to the time leaf templates, but that's all right. So we've got our application where we can sort of, click and find owners. It's got its own HSQLDB, so we can add new pets. So the interesting view is actually on the Elasticsearch side. So this is my uptime monitoring view. This is where my heartbeat component injects, basically periodically does sort of ICMP monitoring and GET requests. So it does GET requests to my application, sort of clicking on Pet Clinic owners too. And I basically see it as some sort of synthetic transaction monitoring. So I just periodically inject a transaction into an application, and my backend APM just measures how long this transaction takes, which is quite a useful way. If this transaction is side effects free, I can get a monitoring what is actually happening. How's my entire application end-to-end is behaving. So it's quite a useful way to perform monitoring, so from the synthetic transaction monitoring perspective. So we're using some GET methods to see if my APM server and Kibana are up. So let's just do that. And I'm doing some ICMP packets to my other infrastructure, to my Elasticsearch and Pet Clinic and Nginx, just to see that the components are running. And in return, I'm getting a nice graph saying how many pings over time and how many sort of servers are up, how many are down. So for example, increase it to say 2 hours, hit apply. It'll show me some reds because this is when I started the application. This is when I started the demo. So some of the components were down. So heartbeat and APM is quite a useful feature. Now, if we go into APM, so this is what we want to see. We see our two services. So we see the front end. This is the Pet Clinic running in the browser, and this is my Java running in the backend. Right, two components. Now, if I go into Pet Clinic front end, I can actually see, well, this is, for example, my find user transaction. Right, let's just see if they distribute a trace. So this is basically an end-to-end view taken from the browser perspective. This is me navigating to owner's find URL within the browser. And this is, for example, where my browser makes a backend call to my Spring application. This is my Spring application basically running owner controller init find form. So it's a servlet API. The agent detected the servlet API and was able to dispatch it to find owners, basically find owners page. Then it got the response back. So we had the browser event sending, time to first byte. So this was event basically when the response is starting to come back to the browser. This is where I'm parsing the document, loading a style sheet. This is where I'm firing content loaded event. So key browser events, go interactive, first content pane, and this is where the page becomes ready. And everything is basically timed. Now, along the way, we're capturing everything related to that particular leg of the transaction instance, right? So we can see all the metadata, so language names, basically, agent versions, and so on and so forth. So we can see all the key sort of labels added, well, nothing in this particular. We can see how much of the transaction time we're actually spending here, how long it took, and then we can see which transaction, which component is responsible for. Right. So this is the end-to-end metadata for that particular request. Another useful pieces of information, so if we go to, for example, we'll look at Java, which is the monolith, right? It'll show us the visualization. This one is 24 hours, but let's just do it 15 minutes. And this is basically the graph showing me how long did I spend in every particular span within that particular transaction. There's a breakdown of how many transactions we had and requests per minute and transaction durations based on 95th, 99th percentile. Transaction serviced by this component. This is a useful visualization. It's a transaction duration distribution. So over time, I can see on the left-hand side is going to be my slow transactions. My fast transactions. On the right-hand side, these are going to be my slow transactions. So this one is, there's a particular request that took 53 milliseconds, and this particular side is taking like 4 milliseconds. So if you go into here, I can see that just transactions basically executed by this transaction is executed by this particular component, and this is where we're introspecting database operations, right? So to the point we can actually see what select statements my ORM framework was running. Right? Again, to appreciate that, just think of it, it's completely hands-free. We didn't do any instrumentation of the Java code. It's all auto-detected by the agent. Okay, so that's quite powerful. So you can actually see which SQL statement we executed, how long it took, and so on and so forth. Right? So this is basically detecting a servlet API, and this is detecting a JDBC APIs. Okay. Alongside sort of, because we're already instrumenting a component, right? We can see errors. So let's just go and create an error. There's an error, which goes blank, which hopefully gets captured. So we can look at the errors. Errors? Oh, here we go. Here's my error. So when we capture unhandled exceptions, we can actually link that exception to the actual line of code where the exception occurred. Just a stack trace that we log in Elasticsearch, and it's captured by the agent. You can see, different sort of occurrences of errors at different times, which is quite useful. So you can actually capture the exceptions, both sort of user-originated exceptions, your timeouts, and so on and so forth. And last but not least is the matrix. Because we're running in a JVM, we can actually get a view of CPU utilization basically for that particular JVM. We can get system memory usage, we can get heap memory usage, we can see some garbage collection spikes basically going up and down, getting non-heap memory utilization. So the agent is running there, it can actually collect a lot of useful information from the JVM, just out of the box. Thread count, for example. So it's quite a lot of good stuff, like just being done by just attaching the agent to your JVM. Now, I mentioned that everything that's happening actually becomes an index in Elasticsearch, right? And we can just go and look at the data that we're collecting. So they all become essentially like documents in Elasticsearch. So you can actually visualize them any way you want to, right? So a particular thing, we're measuring a latency here, so you can visualize latencies. One useful use case I saw basically looking at your transaction latencies today versus your transaction latencies last week, just kind of having them side by side and seeing if you did a release or comparing individual releases between themselves, so seeing if I'm improving latency, I'm breaking latency, so what's happening. So that's basically the information that we log. So everything we log just becomes a Elasticsearch record, so even the APM data. Go back to the APM. ensure there are setup instructions. So if you download it and you wanna know how to install things, there are instructions to install it on Mac OS. There are instructions to install different agents. So it's not just Java, but you can do a lot of other agents. In general, there's quite a lot of stuff. There's quite a lot of good stuff in the stack itself, apart from it, because we keep finding problems that tend to be solvable by search over and over again. So when you have a hammer, lots of things start to look like a nail. I wanted to show you basically the search bar. So if we go and look at the traces, so this is my trace. We'll always get a search bar. So we can say, and there's a sort of a type ahead prediction. So anything with bars actually, you can search on it. So you can say, give me a transaction duration greater than 0. Well, they're all greater than 0. So you can actually search for things. So this is the greater than 0. And having a search engine behind that is actually quite useful because it can search pretty fast. So you can say, for example, also for enumerated values, we can see what's my so user agent name column Chrome. Right? So this is the system basically suggesting what. Refresh. So these are all my user agent Chrome. So these are all my Chrome users. So it will just filter that for Chrome users. Any questions? Yep.
This is interesting when you see the APM from a single service point of view. How does it play out in a microservice environment where the microservice runs on different JVMs? How does that configuration work? Like who you set up?
Yeah. So essentially what you see here, we have two services. We have the front end running in the browser, and we have the Java running in the backend, right? In my environment, so front end is running in Chrome, and the backend is running in a Docker container. So essentially, but you can see that, you can say that in the microservices space, I'll have like chains of services calling each other, multiple JVMs, and other technologies. I'll have Node.js, I'll have Python. So how do we stitch them together? So in this particular case, we're passing a trace ID in a HTTP header. So we generate, so my front end is generating a trace ID. So if you look into say, if I go into developer toolset, and I'll look at my, basically at my request in the network space. That's too small.
Request ID?
So we should see a request handler. Yeah, it's going to be a request handler basically. Yeah. Saying this is the trace ID that I've generated.
So with that probably,
Yeah.
Okay, I get it.
So for HTTP, it passes a trace ID between different calls. If you're using, for example, JMS, we understand JMS as well. We can basically populate the JMS header. If you're using something like, I don't know, Kafka, we give you a method to implement basically, to pass a lambda that basically just puts this value in that header, and then you implement the transport protocol side of things. So if something that we don't handle, so we handle JMS, we handle HTTP or HTTPS. Like if you've got MQ, for example, if you've got Kafka, I think we do understand Kafka now, but I'll have to double check that. So you can pass it through your own protocol. Yeah.
If you have multiple systems talking to each other, they don't have the same correlation ID. Is there a way to correlate and stitch those transactions together by different IDs, right in your own query?
So we already stitching them together. So if you look at, so let's try and search for them, right?
But without the same transaction ID.
Yeah. So we generate trace ID. So we can see what the trace ID is. So this is our trace. right? So this is the trace ID that we generate. So your, in our case, real user monitoring component, so the agent that's running in the browser, generates that trace ID and sends it back to the backend. So in the backend, when they see a request, they extract the trace ID and they, both components, they log into Elasticsearch with that trace ID. So then the UI can actually dig up all the spans and all the components connected to that trace ID. So let me show you. So you can take that.
But
Go
in
into
case,
Discover.
if you can correlate by this trace ID, if
Yeah.
you have, for example, ID in a payload of transaction, is there a way to extract this ID from the payload and correlate on the other end?
So you're asking whether we can correlate based on your own provider ID?
Yes. Yeah.
You don't need to, because we do the correlation, so we generate the correlations, but what you can do is you can create labels. So you can annotate transactions with labels, and labels can be whatever you want. Now we extract HTTP header. If it's coming in the HTTP header, we'll capture it, we'll stick it into a transaction. You can also take control in your code and say, get the current transaction, get that particular, I don't know, trade ID, and stick it into a label. Now, you'll get indexed, the label will get indexed into Elasticsearch, so then you can find it. So this is, for example, documents, all the documents logged into Elasticsearch that correspond to that particular trace ID. So in your case, you'll be just, instead of looking for a trace ID, you'll be looking for a label equals blah, right? So you can find all the related transactions, and more so this is the power of having Elastic Stack doing logging and metrics. If you, for example, your application also logs this transaction ID or trace ID into a log file and you're sending log to Elastic, you can find that transaction, all the log entries corresponding to that transaction ID. So if you're, for example, using something like MDC, log4j MDC, so I can't remember what it stands for, but that's a way of correlating. It's almost like doing APM with logs before sort of APM existed. It's not log4j has its own kind of way of doing that. So you can actually correlate between APM and logs. So you can see what logs did my application create during that particular time frame. More so because we have the time frame, so we can say, zoom in into that particular time, right? So let's just, like, this is where my transaction was logged. And by zooming in, I'm actually creating a time window. So I can take that time window, I can take my filters, and then go and look at my metrics. What were my metrics? What was my CPU utilization of my Docker container, or my Kubernetes host, or my database server within that time frame? I can use that time frame and just look at different pieces of information in Elasticsearch, right, preserving that particular view. So it's not just correlation IDs and trace IDs, you can also use time as a natural way of joining between data and different indices.
Yep. Probably when you're dealing with some sensitive user data like passwords and things, is there an option to exclude or mask certain fields so it's not readable in a production environment?
Yeah, so trace ID, APM agents have like a setting that can say, don't log these particular fields, don't sort of block these particular values. You can do that. You can also go on and just run periodic updates, just kind of clobbering everything that's logged, just sort of belt and braces approach if you're like not certain that the agent is doing that. You can introduce something like logstash. You can push your traces to logstash and make sure in logstash that there's no field value in that, matching this particular parameter. So there's multiple ways of doing that. Yeah. Sorry, I was ignoring you for.
Okay, so the alert based on the digits, right?
Yeah. So we have alerting in Elasticstack, which is just a way of running a query against whatever you want, whatever data you want. And if the data evaluates if the query evaluates true, then raise an alert. Say, send me a PagerDuty message or do a webhook call. Now, our alerting is not part of open source. It's a premium feature. So, but it's there. We also have machine learning that can basically track anomalies, but again, it's not an open source feature. So I'm not going to show you. I just want to say at the end that everything you see here you can use for free, right? So I'm not going to talk about the paid features.
So previously you showed the errors, right?
Yep.
So whenever there is an error, is it possible to pull the payload that is sent for that particular request, which caused that error?
The short answer is well, no, and it depends. Because if you're recording, like it's all about how this exception is thrown. So if you're throwing an exception with some sort of data in the exception itself, like invalid transaction with transaction ID, then we will catch this exception and we will capture it in the log.
Yes, so
If it's just a runtime exception, whatever comes in, we'll just capture it. We don't know.
so maybe the headers or something like that, because in a real world scenario, some exceptions might occur only for a specific
Yeah.
user. Okay, so maybe getting the correlation ID for that particular request or the user details or header details.
Yeah, so you can capture exceptions yourself through the API. So you can, apart from auto instrumentation, APM has API. So when you basically, including the agent as your Maven dependency, for example, you get full access to APIs. And by the way, we provide two flavors of APIs. So it's Elastic APM APIs and Open Tracing compatible APIs. If you're familiar with Open Tracing, you only use Open Tracing. So you can actually capture your own exception. So you can basically say, I want to capture exception for that particular user with these values, and you can just push it into Elastic using the API. So that's there. You can do that. Yeah. Just going to bring back the Elastic APM. No questions? Cool. So this is where I can say everything I've shown you so far is free, so you can just download it and use it. So that's why I haven't seen it. Obviously, it's free to use, unlimited production use if you're self-hosting it and deploying it in your own service. Elastic Stack is open source and free. There are certain paid features we sell support, we sell hosted Elasticsearch, but APM is free, so it's very easy to get started if you're interested. So this is what we saw. The other reminder that we started our discussion from uptime monitoring. Uptime monitoring is another way of monitoring your application. So if you have your users, say for example, deployed around the globe, it's a good way to actually capturing what latency a user is seeing, whether your endpoints are up or down. It's kind of so instead of writing a cron jobs that just do pings and curls, you can use heartbeat and uptime monitoring to basically record it into Elasticsearch. This data becomes an index in Elasticsearch. You can visualize it, you can use out-of-the-box UIs, or you can build your own visualizations based on that data. So that's another thing which is part of this demo. Everything you see here is, I'm going to make it available through a GitHub repo. So you can just download the Docker Compose up, and you'll have the same environment flavors. Presentation. Any questions, last comments, remarks?
How would you compare Elasticsearch, especially the logging service, as when you see Splunk as an enterprise service? Because most of the Splunk has all the similar things, more sophisticated things. So how would you compare? Why would I choose Elastic over Splunk?
So how many of you are using Splunk in your day jobs? Okay, cool. Your hobby projects at home? None? Okay.
That's Elastic.
So you can't afford it.
500 megs offering.
And where does it get you? 500 megs. I tried to see how much, like, if you put a Linux server and just logs, it generates like almost a gigabyte in file logs, just a day. So, okay, I've got a day worth of logs, what can I do with it? Nothing. I always like, if we end up in discussions again, Splunk, like, so I'm always saying, so why am I here? Why are you, like, if you should be very happy to use Splunk, so why are you kind of turning it around? People's like, well, yeah, it's expensive, but it's like, let's assume it was free. What's the other problem? It's a bit slow, right? Because there's two conceptual differences how Elastic Stack works and how Splunk works. Schema on read versus schema on write. So we are very meticulous with how we ingest our data. So we do all the indexing up front, because like, Elasticsearch is a search engine, which means when it comes to search, you want to be like, you want to do the Google experience, right? You want to be, so just run the query, get the results back. You don't want to wait for it. This is why we pay the tax once on the way in. So we had to index the information on the way in. So when you come to search for this information, it's already parsed, already indexed. Splunk works a bit differently. It's a schema on read, which means every time you search for Splunk, it has to parse the data. But it's easy to get the data into Splunk. It's very easy. You don't need to parse, just chuck everything into it. They don't charge you for putting the data into Splunk. They charge you per ingest and index data. So that's what when you need to search through the data, this is where you're going to pay them. Which incidentally is the kind of thing you want to do with logs. You want to search for them. You don't want to just logs sit somewhere. So that's kind of the main difference. It's not the price. It's just the how quickly you can get stuff back out of Splunk. And that actually makes a big difference, not just in APM or logging or matrix case. It makes a massive difference in security case, where you want to kind of reduce the dwell time of an attacker in your framework. You want to search for things because then you want to ask a lot of questions so you can validate or disprove your hypothesis, so you can actually decide on things. If you can only ask one question because you don't know when it's going to finish, you're not going to ask any more questions, you're going to act on it. So I think conceptually that's where the two tools are different. It's not the price, it's the how quickly it is to get the information out of it. But it's a good technology. I mean, back in the day, they were great, like, just aggregating all the machine data into one place, giving you some sort of dashboarding capability. That was good back in 2010. Yep.
I guess it's been used in different projects. So, what is the approach to code profiling with in conjunction with APM? Is code profiling applied on APM? Is that like one succeeds the other? Part of diagnosing.
So what's the relationship to code profiling, between code profiling and APM? So you can think of APM is a very sort of crude way of profiling your code because it measures certain things that matter, right? It's not going to profile every single line of your code unless you instrument it, but it kind of tries to capture like things like servlets, JDBC calls, API clients, so HTTP clients, HTTP servers. It kind of tries to capture key things, giving you the API to instrument other things. So it's kind of is profiling, but I'd say it's a much sort of coarse-grained profiling compared to code profiling tools, specialized code. I can't really think of. Yeah, but it's something that you can also run in production, not just development. Code profiling, I don't think you will be doing code profiling against production system. APM, you actually do want to run it against production system and non-production as well, because it's going to give you a lot of useful information about your user behaviors, what browsers they're using, how much time they spend in different sort of activities, what's the volume. It gives you a lot of different sort of useful information, but you wouldn't run code profiling in production.
Yeah.
So APM is almost like, think of it as code profiling for production as well as non-prod.